we are going to start a new topic called common catenary. So one of the very important topic. So I think a few times actually it was asked in UPSC. So you understand the concept, and this is very easy concept, right? So common catenary. Right? So a common catenary. So before common catenary, first actually we need to understand what is a catenary. So catenary, any string which is tied between two different points where the 2 points are not on the same vertical line. This is called a catenary. That means, suppose this is one particular point, and then this is one more point, and then between these 2 points there is a string that got tied up. So usually like in electrical poles, right? So you might have noticed that electrical wire which is connected between two different poles is nothing but a common catenary, right? So here actually there is one pole here and there is one more pole here. So this is pole 1 and this is pole 2, and this is the string. And the shape that is going to form, right? So this is what is called catenary. So this is what is called the catenary. The condition here by definition, right? So these 2 points A and B should not be on the same vertical line. Suppose if I say that this is point A and this is point B, then actually you cannot call that as a common catenary. So that is by definition, right? So this is how actually a catenary is defined. Now what is a common catenary meaning? So this particular string, whatever is tied up in between, here actually we are not talking anything related to the weight of this particular string or the uniform or the distribution of the mass along this particular string. Suppose if this string is having a different mass at different lengths, then it cannot be called as a common catenary. It has to be called as a catenary. So the difference between these two is, suppose there is a string like this, and this is how the string is there. So this is the string. This is just a catenary. And this, in this particular case, the mass is uniformly distributed between the two different points, right? So this entire string is having uniform mass. So if I say that uniform mass across entire length of the string, then it is called as common catenary. So this is not a common catenary. But this can be called as just a catenary. Got it? So this is also called as uniform catenary. So by definition, a common catenary is a string tied between two different points which are not on the same vertical line. And the string mass is uniformly distributed across the string or entire length, over the entire length. is called a uniform catenary or simply a common catenary. Got it? So this is what is the definition of a common catenary. You can note down this. Okay. Now actually from UPSC point of view, what we need to learn is the equation of the common catenary. So there are different forms of this equation. So one is the intrinsic form of the common catenary equation. Another is the Cartesian form of this common catenary equation. So you need to understand the meaning and implications of those equations along with the interpretation to calculate different parts of this common catenary, right? So the first and foremost is the intrinsic equation. Equation of a common catenary. Intrinsic equation of a common catenary. Now, this common catenary, let us say it is tied between two different points. So, this is the common catenary. Let us say I call this point as A and this is point B and this is point C. Right? So now actually this is the length of this string. So this is how. So BAC, let BAC is the string tied between two different points. B and C, and whose bottommost point is at A. So this is a string actually, that's what we have considered. Now actually, if you randomly consider a point on this particular string, let us say I have considered a point at this particular location. Now, so here I call this point as P. Then actually the portion of the string from here to here, it will be under equilibrium with what forces? So what are all the forces that are acting on this duration AP, which will make this string under equilibrium condition? What are the forces you can think of? What are all the forces that are acting on the string AP to make sure that this string is under equilibrium condition? Any guess? So there will be three different forces actually that are acting on this particular string AP to make sure that this AP is under equilibrium condition. One force is the tension at this particular point, which will try to drag horizontally like this, because this is the bottommost point and the tension is always tangential to the point of consideration. So here the tension which is acting towards this direction, so this we call as T0, and this is the place actually where the string is having the lowest point. So at this particular point the force will be exactly in the opposite direction to make sure that this string is under equilibrium condition. There will be one more tension at this particular point and which is acting like this. So this is tangential like this. So this tension is T. So this is T0 and this is T. And then here actually the mass of this particular string is concentrated at the center of gravity. Now here this is the place actually where the mass is acting downwards because of the center of gravity. So this is CG and the weight of this string Now earlier actually when we considered a string, right? So we considered actually the tension is same across the string, correct or not? In the previous problems, whatever we have calculated, so under equilibrium conditions, right? So we have treated if at all there is a string, the tension in the string is actually treated exactly the same value. But here if you notice, here the tension is different and here the tension is different. So in the previous problems, whatever we have calculated, right? There the assumption what we have made is the string is having no mass. Got it? Here the mass is distributed. That means there is an associated mass. So earlier one is the ideal case. Now this is the practical case. So because of the weight that is acting on this, so it will be acting downwards at the center of gravity. Now that weight we need to consider. So here let the mass per or the weight per unit length of the string be small w. So small w is the weight per unit length. Now total weight is nothing but W is equal to small w into L. So this is the total weight of the string. Now for this particular case of length of, let us say, I call this length as S. Let the length of the point from A to P be S. So if I call this length as AP equal to S, then the weight of the string AP is equal to W into S. So that is the weight of the string which is acting at the center of gravity of the length AP. So this is the place. I call this point as G. Got it? You note down till this point. Done? Okay. Now actually we have to write the equilibrium conditions for this. Now if you notice this T, if I extend like this, somewhere actually it will definitely touch the x-axis with an angle of psi, right? So this is the tension which is acting with an angle of psi with the horizontal axis. So this I call as the x-axis with the horizontal axis, and this I call as the y-axis. Now actually here if I notice, right, I have not taken the origin at this particular location. I have taken origin somewhere below. Why I have taken that way? So I am going to explain in the later part of the discussion. So for now actually imagine that there is an origin somewhere here, and then I have drawn an x-axis like this, and I have drawn a y-axis like this, and then the minimum most point is on the y-axis, and that is at x is equal to 0. Got it? Now if I extend this tension like this, it is making an angle of psi with the horizontal axis. Then I can divide this particular tension into horizontal component and the vertical component. So horizontal component will be T cos psi, because this will make angle psi, T cos psi, and the vertical component will be T sin psi. This is the vertical component. Now there are two different horizontal forces and there are two different vertical forces here. So one horizontal force is T cos psi and another horizontal force is T naught, which is acting opposite to T cos psi. Now for the equilibrium of this length AP, these horizontal components has to be same. Exactly in the similar manner, this vertical component of the force has to balance the so the vertical component which is acting downwards, which is nothing but the weight of the string, for this length of S. So this weight is W into S. So where S is the length and W is the weight per unit length. So this Ws is going to be balanced by T sin psi. Now if you notice, all the three forces together are under equilibrium condition. If these three has to be under equilibrium condition, if you notice, so this extension and this tangent should meet at one point where this is passing through, because these three forces has to form the triangular law of equilibrium. Got it? So here actually, so this is the point of application, or the resultant of these two has to be balanced by this one. Then only this string is under equilibrium condition. This portion of the string is under equilibrium condition. Now, if you equate this horizontal component and vertical component, so T naught is equal to T cos psi and then Ws is equal to T sin psi. So this is equation number 1 and this is equation number 2. Now if you take the ratio of these two, so equation 2 by equation 1, so this is tan psi, T sin psi divided by T cos psi is equal to Ws divided by T naught. Now this T will cancel out and this is tan psi is equal to W into S divided by T naught. Now this W into S is there. Now W is a constant for a uniform catenary. Now T naught also, if you are able to express as a product of W, then that will be easy to understand or actually easy to remember the equation. So that's why there is a parameter called C is defined. So let C be a parameter where T naught is equal to C times of W. So this is how actually this parameter was defined. So based on this understanding, T naught is the horizontal component of the force or the tension that is acting at the bottommost point, which is exactly horizontal or parallel to x-axis. And there actually this T naught value, if you are able to find out a value, a random value C, where C into W is equal to T naught, and this C is called as the parameter. So this is actually, this was brought in to make the equation simple. So nothing more than that. So now actually if you replace here, tan psi is equal to W into S divided by W into C. So W will cancel out and S by C is equal to tan psi. Or S is equal to C tan psi. Now if you notice, this is a very simple equation. S is equal to C tan psi. Now at any instant, right? So you want to find out this length of the string with respect to this angle of psi. Then there actually the S value you can easily calculate C into tan psi, where C is defined by the horizontal tension at this particular point. So this is what is called as the intrinsic equation of the common catenary. So this is the intrinsic equation of the common catenary. You can note down. S is equal to C tan psi, where C is the parameter and psi is the angle made with respect to x-axis for the tension. Now actually, to be specific, these things actually we will put it in words so that we can be very much clear on this. So T naught is equal to C times of W. Now if I call this is equation number 1, this is 2 and this is 3, then so there are different conclusions actually we can make out. So one conclusion is the horizontal component of the tension is always constant or is constant throughout the string. and is equal to the horizontal tension, or this is the total tension also at the bottommost point of the catenary. So this is the first conclusion. So if you notice, wherever the tension, if you try to calculate it, now actually the tension actually has to cut the x-axis with certain angle, and the t cos psi at that particular location again has to be equal to the opposite component of the force, which is nothing but t naught. That means, so the horizontal component is always t naught at every location of this entire string. This is the explicit conclusion. Got it? And then the second conclusion you can make out. The second conclusion is the vertical component of the force is nothing but t sin psi is always equal to the weight from the bottommost point till the point P, and then that is acting at the center of gravity. So this component and this component are one and the same. That means, so the weight actually from this location to this location has to be balanced by the vertical component of the tension. That is the second conclusion. Got it? You note down this. The second conclusion is the weight of the string from the bottommost point to the point of consideration is always equal to the vertical component of the tension. And this is the second conclusion. And the horizontal tension is always equal to the parameter multiplied by weight per unit length. That is the third conclusion. So that is this one. You note down this. I'll write the third one also. Now the third conclusion is the horizontal tension is always equal to the weight contributed by a length of the parameter C. So that is T naught is equal to W times of C. So this is the third conclusion. Done? Now the second important part is the Cartesian equation of the common catenary. So this is actually the intrinsic equation which will give the relation between the angle made by the tension with the S value. The S is nothing but from the bottommost point to the point of consideration, which is the arc length till that particular point, right? Now the Cartesian equation of the common catenary. Now to consider the Cartesian equation, now we have got S is equal to C tan psi, where psi is this angle. Now I can call this psi as the derivative at this particular point P, right? Yeah, right. So this is actually for our analysis purpose, but catenary can be top and bottom also. Vishal, actually I am explaining to you. Now actually, suppose if B is at a higher point than C, then it may not be at the center, right? So that's why actually when we deal with the common catenary, we are dealing with only the cases of where these two are under equal height. Now in such case actually A will always be under the midpoint. Got it? Okay. So now actually y is S is equal to C tan psi, where tan psi represents the slope of the catenary at that particular point, at point P, and is equal to dy by dx, assuming that the horizontal axis is x-axis, horizontal axis is x-axis, and the vertical line passing through A is the y-axis. So this is nothing but dy by dx. So this is nothing but the slope of this tangent, which is equal to dy by dx. Then S can be called as C times of dy by dx. C times of dy by dx. You note down this, we are going to erase it and then write it. Now, this equation we have got in the simple form, S is equal to C times of dy by dx. Now, I wanted to solve this differential equation, and S is a parameter, right? So, S can be a variable value. Now, actually, if I take the S variation along the x direction, that is ds by dx, actually if I calculate it, this is going to be C times of d square y by dx square. C times of d square y by dx square, or this is C times of d by dx of dy by dx. So I just took the derivative on either sides. Now this ds is nothing but if I take an elemental arc, suppose actually if I take an elemental arc from this location, so this is the arc. So this arc actually is having a horizontal length of dx and is having a vertical length of dy, and this arc length of ds. So as dx and dy tending to 0, ds will tend to 0, or actually it is as if like it is a straight line rather than a curve, right? So if delta dx tending to 0, then ds can be treated as a straight line. ds can be treated as a straight line. Now actually this triangle, I have enlarged this equation. So this is ds, this is dy, and this is dx. So from there actually ds square is equal to dx square plus dy square, as per Pythagoras theorem. So why we have taken this way is, if you want to solve this equation, you need to introduce this method. So these are actually higher order differential equations, or actually in fact non-linear differential equations actually we are going to get it. So in this actually one of the method actually, that is through Char-Pit method actually we are going to solve this differential equation. So the complexity here is S is equal to C times of dy by dx, and where S is again, so varying with x and y together. So that's the reason actually the non-linear differential equation is going to come in. So hence actually this is one method which you can adapt it. So here actually if you replace here, so ds square, or actually so ds is equal to square root of dx square plus dy square, under root. If you replace it here, so ds by dx is equal to square root of dx square plus dy square whole divided by dx square. So this is ds by dx value. So this can be written as 1 plus dy by dx whole square under root. Got it? Note down this. Okay. So now actually, if you put this relation in the above equation, what we are going to get is, so ds by dx can be replaced with 1 plus dy by dx whole square under root is equal to c times of d by dx of dy by dx. Now let p is equal to dy by dx. So this is a new parameter actually what we have introduced here, and this method of introduction is called as Char-Pit method. So Char-Pit's method of solving differential equation. Here actually if you notice, these are actually non-linear differential equations. So non-linear differential equations we are going to solve it now. So 1 plus dy by dx. So this is actually, so this is out of syllabus for UPSC, but actually for understanding this common catenary, so we have to be adopting this method. So 1 plus dy by dx is 1 plus p square under root is equal to c times of dp by dx. So dp by dx. Now actually if you notice this, you can solve it. This is a first order differential equation. Here p and here p. So dp by dx is there, you can easily solve it. So dx by c is equal to dp by 1 plus p square under root. So this is actually by variables or separables method, you will be able to solve this. So here actually if you simplify this, x by c plus a is equal to, so 1 by square root of 1 plus p square. So this integral is sine h inverse of p. So this is the differential equation solution. Got it? So you note down this. So this is not the end. So the Cartesian equation of the common catenary is nothing but you have to establish the relation between x and y. So here actually we have introduced p, where p is equal to dy by dx. That also needs to be eliminated. So first actually you note down this, we are going to do that. Done? Integral part. So this integration dp by square root of 1 plus p square. So this integration actually you should be aware of. So this is plus 2 standard. So p actually you can assume as sine hx, and then actually square root of 1 plus sine h square x is nothing but the cos h square, and the derivative cos h square numerator it comes. Both will cancel out and then you will get the answer as p, which is equal to sine h naught. Yeah. Got it? You have introduced some random variable t is equal to p is equal to sine ht. You introduce this and then just find out dp by dt value and then put it here. Everything will cancel out and then finally you are going to get as t, and which is equal to sine h inverse of p. I hope I don't need to explain this. Got it? Okay. So now actually we have got the intrinsic, so this equation x by c plus some constant a is equal to sine h inverse of p. P is nothing but dy by dx. Now to understand this constant value or to find out this constant value, let us consider one point which is convenient for us, this particular point a. So let us consider a point a on the catenary. A on the catenary where x equal to 0, dy by dx is also 0. So if you notice this point actually that is located at x is equal to 0, and correspondingly if you notice the derivative is nothing but the slope of the equation. So the slope is nothing but parallel to the x-axis. Hence, so parallel to x-axis, you are going to get the slope as 0. dy by dx is equal to 0. If you put it here, 0 by c plus a is equal to 0. Sin h inverse of 0 is again 0. So it implies a is equal to 0. So we have got the simple relation x by c is equal to sin h inverse of dy by dx. Or if you put on the other side, dy by dx is equal to sin h of x by c. Sin hx by c. Now actually you have to find out the integral of this, so that you are going to establish the relation between x and y. So dy is equal to sin hx by c into dx. Now you again integrate it. So it implies y plus b, or y is equal to, so integral sin hx is nothing but cos hx. So cos hx by c, and then what is the factor that is coming out to be a product of x has to come at the denominator, that is divided by 1 by c plus some constant b. So this is y is equal to c cos hx by c plus b. Now here actually the importance of y we are taking at the bottom of this minimum most point for eliminating this b. So this b actually some random constant which got in now. So you wanted to identify b is equal to 0. Correspondingly these values actually you are establishing it here. So here actually, so at x is equal to 0 and there is some y value. At x is equal to 0, there is some value if you can introduce here, that is let y is equal to c, then b will be 0. Got it? So here actually, if I make x is equal to 0, this is going to be 1. If this is 1, c will be left over here. Now we have got the relation y is equal to c plus b. Now if I make y is equal to c, then b will be 0. So that actually the arbitrary constant actually we have got with the integration, you can eliminate by making y is equal to c. That is why I have taken the origin which is somewhere below the minimum most point at a height of c. So this height is c. So that I can eliminate b, or b I can make it 0. Now I have got the simple equation. So y is equal to c cos h of x by c. So we have got the final relation y is equal to c cos hx by c. So this is the Cartesian equation. If you notice, only the constant parameter and x and y are present in this equation. Hence we call this as the Cartesian relation. Got it? So Vishal, sin h derivative and integral cos. Yeah. Okay. Fine. So you have got a clarity on this common catenary. Any questions on this? So there are two different forms of common catenary we have introduced. That is, one is the intrinsic equation, which is simply the parameter length is expressed as a function of the angle psi. So S is equal to c tan psi. This is called the intrinsic equation of the common catenary. And the second one is the Cartesian form of the common catenary. So indirectly, actually here what we have learned is the Char-Pitts method, which is nothing but a one form of identifying the nonlinear equations to solve. So that is nonlinear differential equation what we have got in the first order. We have introduced a new parameter p in place of dy by dx and then tried solving for p, and at the end actually we solved for p. So in between actually to eliminate the arbitrary constants that are coming in, so we have selected y value which is down below this minimum post point at a length of c, so that I can eliminate all the arbitrary constants. So if you notice in the x-axis, right, it is at a height of c. So with this understanding, this x-axis and y-axis, the common catenary equation is y is equal to c cos h of x by c is nothing but the common catenary equation in Cartesian form. Clear? Any questions are there? Any questions? Oh, great. So now actually the terminology is actually what we are going to use in case of common catenary. So that I am going to explain. So the parabola terminologies, whatever we are using, right? The same terminologies actually we are going to use even here also. Now here the terminologies are this line, the y-axis is nothing but this is the axis of the common catenary. This is the axis of the common catenary, and this minimum post point, this is called as the vertex of the common catenary. So this is the vertex of the common catenary, and this x-axis is called as the directrix of the common catenary. And this length of BC is called as the span of the catenary. And if I call this point as D, then AD is called as the sag of the catenary, sag. Got it? This is the sag. And this is span. BC is the span. So C is called as the parameter of the catenary. And intrinsic equation is S is equal to C tan psi, where psi is the angle made by the tension with x-axis. And y equal to C times of cos hx by C is the Cartesian equation of the catenary. Got it? C is a simple constant which will represent the distance of the length of the string whose weight is equal to the tension at the bottommost point, which is the horizontal tension. Clear? So these are the terminologies actually what we are going to use it. Then so we have actually other aspects. So I am going to discuss in the next class, that is the different relations actually that are going to be established between this tension parameter S, that which is nothing but the length, and the XY values. So there are different kinds of relations that itself will take one complete class. So that actually I am going to discuss it tomorrow. So after that, so we will be left with only few problems on this particular topic. This is a small topic. And most of the times actually he asks us to calculate the span or sag. Sometimes actually he asks us to derive this intrinsic equation and the Cartesian relation. So these are the ways actually that are going to be asked in case of common catenary. So to be specific actually, so statics is not very tough. So those tough parts are already over. So in the first classes, right? So there actually mostly the confusion is calculation of the moments. So by considering the directions. So there a little bit of confusion is there, and that demands a lot of understanding of geometry, especially triangles, right? A little bit of understanding of circles. So that's why actually you might feel a little bit difficult. So if you know geometry, then actually even that part also is not very tough. So rest of the topics what we are going to deal with are similar to this. So these are actually very, very simple understanding. Clear? Okay. So if you have any questions, you can let me know, or else we can close the class for today. So tomorrow I am going to discuss the various relations that are going to be established between all the variables, whatever we have discussed it today.